So personally, based on my area of research, I'm very excited about what JWST can tell us on the composition or available materials to form planets and compare it to what they're finding in exoplanet atmospheres. I think that planetary connection and understanding the chemistry of planets is fascinating. And then from another point of view, it was very nice to be at a conference where we discussed so much on the impact of astronomy in society, JWST in society, and how we can use astronomy to further benefit all of the world. I think it's very important that we're able to communicate the inspiring findings that we're having with the rest of the people. I think this is a way of showing what good outcomes we can have when we all get together and push forward these amazing discoveries and instruments.
I've learned that JWST is going to make available to us a totally new population of extrasolar planets that we would never be able to access from the ground. That's one thing. I think another thing is that we're going to be able to understand what these planets are made of, what their constituents are, their chemical constituents, and their building blocks. And this is, I think, the beginnings of our ability to connect the compositions of planets with maybe how they formed, a formation scenario. I feel really lucky to be at this amazing place, this amazing institution, and it's really, I feel humbled by the work over 20 years by thousands of scientists, technicians, and engineers, and I feel very lucky to be presenting some of the final fruits of this 20 years later at this amazing place. I feel very lucky and honored to be here.
I think the most stunning results are like the richness in chemical composition in these disks around young stars that form planets. Well, I think what I'm mostly looking forward is to take the diversity of spectra that we see and to start to make sense of it, to understand it in a larger context, like what does it mean for the formation of planets in these disks and how does it map into the diversity of exoplanets that we are seeing currently.
It's incredible what we have learned in just the first year of JWST observations. We are for the first time being able to measure atmospheric compositions of small planets in their habitable zones. This is an example of K218b, which is a planet just about 2.5 times Earth radius, the size of the planet, but we have been able to detect methane and carbon dioxide in its atmosphere, which is really a phenomenal discovery, and for the first time we have been able to make these measurements in the history of the field of exoplanet science. And these are the kinds of planets which could potentially host liquid water oceans on them. We don't know that for sure yet, but there is that potential, so we have started a new era of possibly astrobiology which we will be working on over the next 10-20 years. With JWST in this emerging area of exoplanetary atmospheres, we just want to be open to any sort of possibilities. We don't know what these planets are like. We are talking about planets in what is known as the sub-Neptune regime. This is planets between Earth size and Neptune size, and we have no analogs of these planets in the solar system. So when we want to go out and look at these objects with JWST, we want to remain open to all the possibilities out there, and this will be the building blocks for our search for life eventually, and maybe we might be surprised, maybe we might see some science in the next 10 years, we don't know. So it's a golden era of exoplanet science that is just unfolding, and we want to be prepared as scientists with an open mind to make the best use of JWST.
So far, I think how different the young stars are, how when they form, I think it revealed how much complex the problem is. It's usually we try to look for simple solutions with new observatories, but in the end we find more questions than answers. I think it's really puzzling how different stars can form. Yeah, I think JWST by all means exceeded our expectations of what we can learn about the universe and about the star formation process. I think the images are beautiful, they spark the imagination, so yeah, they make us very excited about the future as well.
So I'm most excited by the fact that we've discovered sub-solar mass young stellar objects in the Small Magellanic Cloud. This really demonstrates how James Webb is transforming the field of understanding star formation. Most of what we know is in the local solar neighborhood, and James Webb has made it possible to do star formation studies like that, but in nearby galaxies like the Small Magellanic Cloud that have conditions very similar to the peak epoch of star formation in the universe. And that's very important because people don't really understand those processes going on. So it's a very critical link to other goals for James Webb, but I'm most interested in these very low mass stars, and we're getting spectra of them to learn also about what's the different chemical composition. And the interesting question is, are we going to see enough dust there that these very low middle-C stars can form planets? And so that's another connection with the interest in exoplanets, like when could an exoplanet form? So I started on James Webb when I was came out of an assistant professor position like 20 plus years ago. And so I tell postdocs that I know, you should get involved in a large mission because it will take 20 years and you will be mid-career when it flies. So I just want to encourage all the young astronomers or aspiring astronomers that the future is bright, and to latch on to these things because we need you to do that.
So I'm studying how the very first galaxies formed and were birthed in the early universe, and we have discovered that there were many more numerous galaxies just after the Big Bang, many more than what we expected to discover. And so there's something that has helped in forming the very first stars and galaxies, and we have not understood exactly what this was. The conference has been a great occasion to hear the spectacular results we got from James Webb over so many fields, but also to reflect upon the impact that our studies may have on the evolution of society and on the understanding of the position of the human mankind in the universe. That's a remarkable impact of these missions.
That the earliest phases of star formation make up a considerable amount of the stars that are being formed that we completely missed with Hubble. Yeah, I thought that a main theme of the meeting was connection. We tend to preach to the choir, so to speak, in many ways, whether it is within our own fields of research, even in outreach. We tend to talk to people who are already interested in our networks of collaborators. There are many people in the world, great fraction of the world that's excluded. And so I felt that a main theme of the JWST discoveries in this meeting was to reconnect.
Just the diversity in exoplanets, the diversity in planet-forming disks, even the diversity in galaxies. So we're just only, starting to get the tip of the iceberg, but there's so much more to discover. It's been a fantastic 3 days, and especially seeing the young people so enthusiastic about all of the work and doing such excellent science.
Oh my gosh, there's so many things. I think the spectra that we are getting of exoplanets, so that we know what the atmospheres are made out of and we can compare those to our planets here on Earth, that's really exciting to me. This was a fabulous meeting because we had so many people from so many different communities that normally they don't talk to each other. And we were able to talk more than just the science, but about why we do the science. It's always a delight having people here, and the friends that I've made, I hope will be friends for the rest of my life.
Well, I must say I hardly knew anything of everything that was told because I'm not a scientist. I think what moved me most was to see the amazement and the curiosity, but also sort of the emotional part of the scientist. When they talked about how they first saw the images, and sometimes you could actually see that they were moved by it, and it was such a revelation. And I think, yeah, that stuck with me the most, apart from all the amazing images, of course. And also the, I think it was called the Hyceanic planets, because it sounds so sci-fi, so that really excited me, yeah. I write a lot about space also from a philosophical perspective, and this really made me realize again how this can really shift our worldview and our view of the universe. But it also made me realize how important it is to convey this to an audience and to make them understand what has actually been seen. So yeah, that's a big challenge, I think.